Greetings and welcome to the Global Spec webinar on laser marking technologies. I'm Bob Henry with Epilog Laser. I'm with you today here at the Epilog headquarters in Golden, Colorado at the base of the Rocky Mountains. We're really excited that you joined us today. Thanks for taking some time to be here with us. Today we're going to talk about the FiberMark laser system typically used for metal and engineered plastic marking applications. We're excited to demonstrate the capabilities of the laser. With the webinar today, we're going to talk a little bit about Epilog. We're going to talk about how the FiberMark laser works. We're going to talk a little bit about material compatibility and the type of marks that you can achieve, and also the advantages of the FiberMark laser system. So with that, again, thanks for joining us. We hope you enjoyed this webinar. Let's get started. You can see from the slide that we put up on the screen here that, again, our laser systems serve a wide variety of different markets. The FiberMark laser, because it's used principally for metal and engineered plastic marking applications, is a smaller group of industries that we sell into. But then again, there are so many different metal manufacturers as well as plastic manufacturers that can use this type of technology that it's just a good representation of the overall picture of markets that we can serve. All right, let's start talking about the FiberMark laser. The first thing that I want to do is to show you the backside of the laser system where we house the fiber laser source itself. So I'm going to spin the laser system around. I've got the back door, or rather the back panel off, so you can see the fiber laser. So I'm going to spin this around, and as we zoom in on the fiber laser, you can see on the back side what we have is what appears to be a bit confusing, but actually this is the fiber laser source. It's a ytterbium fiber. You'll see power supplies attached here. The most important thing, however, is within this fiber laser chassis is the electronics, the diode light packs, and then the fiber optic cables that are housed inside this yellow cladding. The fiber optic cables go through to a collimator here. The red diode pointer that is used, great tool that I'll show you how that works coming up, is housed in here as well. So the laser beam itself is generated within here as it travels through the fiber optic cable and then out through the collimator and the output device. Wanted to show you the fiber, wanted to show you how compact this was. Also important here is that this is air-cooled. Very small. Air-cooled means that companies like Epilog can integrate this product into our laser systems very efficiently, very effectively. We don't have a large footprint. Oftentimes you'll find lasers that generate this type of light will have water cooling requirements, which means that you've got an external water chiller just another complication through the entire process of maintaining the machine. Air-cooled fiber laser, very compact, very handy. I'm going to turn the laser system back around and we're going to start talking about the inside of the cabinet. Inside the laser system, as I mentioned, we're directing the laser beam through a series of mirrors. I'm going to disable the axes here so I can move this around a little bit and give you a little more information. Over here is a steering mirror. The laser beam then travels to the final steering mirror and then down through the focus lens. This is what we call the gantry. You'll notice that we've got a large 24 by 12 workspace in here. This is really advantageous for a lot of our customers because it allows you to do a lot of different things. You can load up many small pieces in this workspace. You can use jigging to put into the laser system cabinet, or you can do very large parts, and by moving this lens assembly around and establishing a new home position, mark anywhere you want on that large space. You'll notice as well that this door has a green tint to it. There's an organic dye in here that will absorb the light energy. It's important to note that all Epilog laser systems are manufactured per the required government and regulatory specifications. We are required to build in safety interlocks on all of the doors. You'll notice we have a top door here and then also a front door here. Both of these are safety interlocked. If you should open one of these doors during laser system operation, the laser beam would shut off. We also have a lighted cabinet in the FiberMark, which is really nice to help illuminate the cabinet itself and illuminate the piece that you're marking on. So with a quick tour of the laser system itself, let's turn our focus now to the software and the print interface part of the laser marking operation, if you will. We're showing a computer here, PC-based computer. The laser systems that Epilog manufactures really act like printers. We do not require that you use a proprietary software. You can use a wide variety of different software types or applications. We find that many of our customers like more of a graphics type of software like CorelDRAW or Adobe Illustrator. We have many customers using AutoCAD or similar CAD packages. For our customers doing a lot of barcoding, Bartender or Label Matrix is a good choice as well. You can print from Microsoft Word or Microsoft Excel if you wanted to, although we don't recommend that because graphically they're not very powerful and they don't provide the operator many techniques for changing font size, style, rotational type of things. So again, a graphics program, we would recommend something like CorelDRAW that we're going to be using for the demonstration today. What I want to do is show you our print driver. We call it the dashboard, and this is where you set all of the laser parameters for a particular job. So I've hit the print button, and then once I've selected the print driver that I want to print to, and this is a good place for me to mention that with our laser systems, you're able to print or send jobs to the laser from the computer via a USB connection or an Ethernet network connection. Networking is by far the most popular with our customers because it allows our end users to print to any networked computer, or rather any networked laser from any networked computer. Simply set an IP address at the laser system, match that up to an IP address in the computer, and you can print to that device. Here we're printing to 3.6, an IP address that we've established at the computer. So we click on the Preferences button, and this brings us to the dashboard print driver. I'm going to go over some of these features in here and show you what these things do. This is my segue to bring you into actual marking on some materials, but let's start with the driver. First of all, we can change the resolution of the marking. We express this in dots per inch, much like the printing industry. Most of the marking that we do with metal and plastics is going to be at 600 or 400 dpi. Of course, lower resolution, the jobs are done more quickly. 1200 dpi is great for those really small objects that you're going to be printing. An example would be 2 or 3 point font. These are really small font sizes. We actually have customers that are using that small a font for some of their marking. We would recommend 1200 dpi for applications like that, but 600 generally is where most of your marking will be done. Raster, vector, or combined, the job type. Raster is like a paper printer where the ink carriage is moving left and right and applying ink to the surface of the material. Same with raster. You'll find, you'll see in a few minutes when we do some marking, that the lens assembly is going to be moving left and right while the laser system fires relative to the graphic image. Vector marking is essentially more like a plotter where we're tracing specific line segments with the laser system. And then combined mode is when you have both a raster and a vector image in one job. This is really convenient. You can send both jobs over with one setup instead of having to send 2 different jobs over. Piece size, here the piece should equal the page size that you've set up in the software. This is a great feature, probably one of my favorite with the laser system. We call it center engraving. This allows you to change the home location within the laser system cabinet. And I'm going to be using this for my demonstrations today to show you how easy it is to change a home position. Again, this is a great tool for those customers that have a large part, maybe an odd shaped part, where they want to place a mark on that location that doesn't really fit quite nicely in the X and Y space in the laser system. Raster engraving settings, we can control speed, power, and frequency, the pulsing of the laser here. Same with the vector. We can control all of those same parameters independent for raster and vector. The color mapping tab that we'll go into next, I'm going to use this for the marking that we're going to be doing as well. This is a great technique that allows you to establish a color for a graphic image and then apply different speed, power, frequency, and focus values to each of those parameters. I'll show you this in a little bit more detail when we bring up our first graphic that we're going to run here. The Advanced tab in the dashboard print driver, this is great as well. We can store jobs in here, so if you're using a common job or running a common job rather every week, you can store all of those settings in the driver and then recall them later. So if I'm running this 3x5 titanium 1C3 today, I would click on select that particular job, I would click on the load button, and then all of those data specific for that job are populated within the driver. We can also update the firmware to the laser system through this portal as well. Very handy feature. So let's back out now. I'm going to cancel here with a quick tour of the print driver, and I'm going to bring up a graphic file. We're going to be running on 3 different types of metal today: stainless steel, titanium, and aluminum. These are what we find to be the most common types of materials, metal materials that is, that our customers are using. Bear in mind that we've not found a metal yet that we've not been able to mark, whether it be anodized or black oxide surface, painted. Again, we've not been able to find a metal that we've not been able to mark with a fiber. Today's focus will be on those 3 materials that seem to be most common in the marketplace. So I'm going to bring up the stainless steel file. This is a file that we've already created to make this go a little bit easier. You'll notice here that I've got 3 different barcodes. They're different color. Let me zoom in on this so you can see that a little bit better. So we've got a red, a green, and a blue data matrix barcode, and then we have Epilog Laser in outline form. This will be our vector image, and these will be raster images. So I'm going to select these items, and then I'm going to go to the print driver again. So I'm going to click on the print icon, and then I'm going to click on the selection because I just want to run those barcodes and the Epilog Laser. If I click on the color mapping tab, actually I'm going to back out and go to the Advanced tab, and here I'm going to search for the stainless steel data file that we've already set up. So I find it here, stainless steel. I click on load, and then again, all of those color map, all of those data for this particular job are populated within the driver. Recall that on the graphic we had red, green, blue, and magenta colors, and you'll see here that the red, the green, and the blue all have different laser parameters that we're applying. Speed, power, frequency, and focus is different for all of those jobs. Click on the General tab. I'm going to select Center because I really want to show you how that works. Again, great feature. At this point, we verify that we've got color mapping selected. We like those parameters. We've got Center selected. We're going to click OK and then print. With that, the job is sent over to the laser system. This is a piece of stainless steel, just sheet stock material that we're going to run. Again, I mentioned that we're going to run this in the XY off mode or center engraving mode. So what I do there is I just grab the lens assembly and drag it around. Perhaps you can see this red spot right there. That's the indicator that that will be the exact center of my graphic. I can set it there, and then once I find the location I like, I hit the Set Home button. The Set Home button captures that location. You'll notice that the servo motors are now locked in place, and we are ready to mark. I hit Reset. I see on the control panel that the graphic file that I've saved in the computer, I call it GSSS for stainless steel, is populated here. whatever I name the job at the computer shows up on the display panel of the laser, which is very convenient as you scroll through the multiple jobs that you can store in here to find the job that you want. Once that's done, I close the lid and I simply hit the go button. On stainless steel, we find that we can achieve generally 3 types of marks. There's some subtle differences between these marks, but generally we describe them as an etch, a polish, and an anneal mark. An etch is actually ablation of the material. We're removing stainless steel to create some depth into the material. The mark that you see going right now is what we say is our polished mark. This produces a kind of whitish type of mark on the material. Many of our customers like this type of mark. It's a bit more subtle, perhaps kind of a watermark type of effect. And then the last mark that we're doing here is what we call the annealed mark. Annealing is the term that's used in the industry. It's not truly annealing the metal. It's actually creating an oxide layer on the surface of the metal. Dark marking is perhaps a better term for use with this particular type of mark, but again, the industry tends to call it annealed mark, so we'll use that convention for today. Raster marking just finished, and then this is the vector marking. Again, more of a profile or outline type of marking. When the job is done, the laser will beep telling you it's done. And you'll notice that there's slightly different colors to those marks. The etch mark here and the annealed mark here look the same on camera, I'm sure, but if you feel them, the anneal mark is very smooth, no ablation to the material, where the etch mark, you can definitely feel there's some depth into the metal. And then of course, Epilog Laser in vector mode. Great marking technique there as well. So that's stainless steel. Let's move now to titanium. Titanium is a wonderful material to work with. We find that with titanium, because of the metallurgical properties of the material, you can get a greater variety of colors in the annealed mode. Depending on perhaps the alloy of titanium, we can find reds, blues, greens, yellows, oranges to come off. Great colors. I'm not sure how practical it is, honestly. It's more of a decorative type of mark, but we've got a couple set up to show you here. So I'm going to open up the titanium file. You can see that I've got a similar graphic, although a little bit different. I'm going to zoom in on this area again. And you'll see that I've got the Epilog Laser logo and the Epilog Laser text here in outline. We're going to engrave or mark these as well. So I've selected this job. I want to do these particular graphic elements back to the print driver. Select the print icon and then preferences. I'm going to go back into the advanced tab and pull up the settings that I've established for the titanium. So you'll see I've got GSTI for titanium. I'm going to select that and then hit load. All of the laser parameters for this particular job are then populated in the driver itself. Again, very convenient for our customers that are doing repetitive work. Instead of writing them down, forgetting them, having to try to reestablish the settings on a particular material, the ability to load those parameters for a certain job, very handy. So again, with the titanium, we've got red, green, and the magenta. You'll also see a black graphic on screen. The black graphic actually is applied to these settings here on the main page of the driver, the general tab in the driver. Back to color mapping, again, speed, power, frequency, and focus is a little bit different for all those graphic elements. Everything looks good here, 600 DPI, center engraving. We are ready to go. Click the print button, click OK, and then print. And again, back to the laser system. At the laser, we've got a sheet of titanium similar to the stainless steel. And we're going to mark on this particular piece. Again, we're going to use the really handy center engraving feature. I'm going to pretend that this titanium is a little bit odd shaped that doesn't really fit nicely into the laser system cabinet, so I need to establish a new home position. To do that, on the control panel of the laser, I hit the XY off button and then the go button, and that disables the axes. I'm able then to drag this anywhere I want on the work surface. That's my ideal location right there. I like that. I then hit the set home button to capture that location. Again, servos lock in place. We're ready to mark. Hit reset. I've got my job loaded in there. It identifies it as the titanium job. I then hit or close the lid and hit the go button, and we are marking. Again, titanium is a wonderful material. You can get a lot of different colors to come off. How practical it is, I'm not quite sure, but certainly from a decorative standpoint, it's wonderful. Reds, greens, blues, gold. We've got a couple of marks in here, a bluish, purplish color, and then more of a gold type of mark. By changing speed, power, frequency, and focus values, we can achieve those different types of marks. So we've got a couple of annealed marks of different color. And then you'll see that we also have an etch mark, just a straight up zero focus etch mark into the titanium material. We've just completed the bluish mark, and now the gold type of mark is being applied to the surface of the titanium. And then the next mark will be the etch type of mark. You can see that there's a bit of reflection coming off of the material. While it may be bright to look at, there are no risks with the actual laser beam escaping the cabinet. This would be the vector marking. Again, when the job is done, the laser will beep at us. We'll take the material out, give it a little wipe, and there you go. You'll see we've got a bluish color, gold, an etch here. And there's definitely ablation of the material there. You can feel that. And then also with this vector mark, definite penetration into the metal. So that's titanium. The last material I'd like to work with will be aluminum. So if we go back to the computer, it will bring up the preset job for aluminum material as well. Here I've got a graphic file already set up. As I mentioned, we wanted to show you the different types of marks you can do. We've done a data matrix barcode, we've done a logo, and now we're going to do just kind of standard serialization. So here are some serialized numbers that we've applied. Again, same process, go to the print driver. We'll find the presets that we've already got for the aluminum material. There it is right there. We'll click on load. And then let's go to the color mapping tab and take a look at those parameters. You can see we've color mapped green, red only, and we have magenta there as well. So we're ready to run this job. Back to the General tab just to make sure that everything looks good there. And we click OK. And again, print. I've got another sheet stock piece of aluminum, and I'm just going to use the same location here. If we look at the control panel on the laser, you'll find that we're in job 4, and it's the aluminum sample. It's in place, ready to run. I've placed the material on the table. I've closed the lid. I'll press go and let the laser do its work. You'll find that aluminum will not exhibit the variety of color like stainless steel and titanium do. Aluminum tends to grade from a light gray, actually a whitish material, to a dark gray. The marks that you see here, the first line of text that we did would be just kind of a standard engraving. The second line, we've slowed it down quite a bit to get more depth into the material. depending on the type of aluminum, we can achieve quite good depth into aluminum. And this last mark is much faster. This will be more of a polish or whitish type of mark on the aluminum. This is actually quite nice as well. Again, many of our customers find that they're looking for perhaps a dark mark, but when we show them this whitish type of mark, they really like that for their particular application. And again, we finish off with vector marking here. So here we've got serialization on bare aluminum. You'll see that the top mark is more whitish in color. The bottom two marks appear to be the same color, but there's actually much greater depth with this bottom mark because we applied more speed, or rather less speed, relative to power. So we got deeper into the aluminum with that particular mark. So again, that's a quick summary, a quick representation of the common metals that are used: stainless steel, aluminum, and perhaps to a lesser extent titanium. But I hope that you get a good representation or good idea of the different types of marks that you can accomplish with the FiberMark laser system. Again, by applying different speed, power, frequency, and focus values, we find the fiber to be an incredibly valuable tool and provide a lot of functionality with the variable types of marks that our customers require. Now I'd like to do a little bit of marking on some engineered plastic material. In addition to being a wonderful tool for metals, the fiber wavelength also works really well with engineered plastics. I've got a piece of control panel plastic here. Actually poses a little bit of a complication because we've got some tabs on the back, so it doesn't fit nicely in the laser system. But I can use a simple jig to put the material in here and place it in the workspace. I'm going to use the relocatable home position technique or function to establish the right location, but first I want to set the correct focus. I'm going to use our focus gauge, hang it on the lens assembly, and then lower the table until it gets fairly close to focus. What I'm trying to accomplish here is to bring the table up until it just touches on the material, which will put the material in the right focal plane to produce a good mark. Once I've got the right focal distance, I'll bring the red diode pointer to the center of that particular piece of material, and then I'll capture that location with the Set Home button. I'll hit reset, and now the laser system is set up to mark this particular piece of plastic. Back to the computer and the software, I'm going to bring up a file that we have here that we can use with this particular plastic, and I'm going to do this FiberMark logo on that piece of plastic that we have in the laser system. So the same process, I go to print and then properties, and this is going to be a raster job. I know that this plastic I can run at about 70 speed, 45 power, and 60 on the frequency scale to produce a nice contrasting mark. This is a great place for me to talk about the variability in types of plastics that are out there. There are literally thousands of different types of plastics, different formulas. Whether or not they all mark is sometimes unknown to us. There are many plastics that mark quite nicely. We know that they mark well. I would encourage you, if you have a plastic material that you're curious to know if it marks well with its wavelength, send it to us. Let us run it through our application lab, and we can tell you pretty quickly if it's a good material for marking with this wavelength. This job appears to be set up. I'm going to click OK and then print. I'm going to do that one more time because I need to do just the selection here, and then I can do the print button. And then back to the laser. Everything is set here. I close the door and press go. You'll see that this particular plastic produces a very nice contrasting mark with this wavelength of light. So again, in summary, with plastic material, we would encourage you to send us some of your material. we'd be happy to run it through our applications lab and assess whether or not it's right with this particular wavelength of light. I'd like to now turn our focus to cylindrical engraving. We manufacture two different types of rotary devices here at Epilog. So we'll scan over and show you the different types of rotaries that we manufacture. The first one that you see on the table here is our standard rotary. We've manufactured this particular device for, gosh, almost 20 years now. We've looked at redesigning it, but it just simply works. Wonderful device for general graphics engraving. You'll notice that we've got a flashlight on here now. To mark with this particular rotary, you just simply place the object here. The rotary provides flexibility for different heights. You can raise and lower this side to accommodate tapered or sloped parts. And you can also move this left and right to accommodate shorter or longer pieces. Again, this rotary is great for general graphics engraving. Wonderful device. If your marking requirements are more stringent, if you have a need to put perhaps gradations or specific marking dimensions around a particular part, we would recommend our 3-jaw chuck rotary. We're going to demonstrate how this works, how we install it, how we set up a graphic job, and how we run that particular rotary in just a second here. Rotary's very, very good. Of course, 3-jaw chuck mechanism on the left here for grabbing the part. We have an idle side support mechanism that allows you to accommodate very long parts. This has about an 18-inch X-axis stroke on it, so we can accommodate very long parts. We've got this really nice centering feature here that allows you to clamp onto this part to hold it nice and straight. So with that, let's go back to the laser, and I'm going to show you how you'd set up this particular rotary to run in the laser. The first thing we're going to do is grab the rotary, and at the laser we're going to lower the table all the way. One thing I'll point out with any rotary that you install into the FiberMark or any Epilog laser is it's important to turn the laser off while you install the rotary. So the first thing we're going to do is hit the focus button, and we're going to lower the table all the way down. Once we've done that, I'm going to turn the laser system off. With the laser system off, I'll move the lens assembly out of the way. I'll collect up the miscellaneous parts that we've already engraved and marked. On the bottom side of the rotary are pins that fit into pre-drilled holes in the table of the FiberMark. So I'll drop those in place. You'll see an electrical connection here that plugs into a port over here. Once I've got this installed, I'll turn the laser back on. You'll notice that the lens assembly is going to come out and park centerline over the rotary device. This, of course, is intentional. One thing I want to point out to you is this display panel here in the laser system rotary. This is actually the diameter of the part. We want to make sure that we have the right diameter. We're going to mark on this part. I've already measured that. I know that it's 1 inch. So in order to get the right movement, the right rate of movement around the part, I'm going to set this to 1 inch. And you see we have different scales that we can apply here. This is 1 inch right here. So we're ready to go. What I'm going to do then is to focus on this particular location. So I'll hit the XY off button, and I can bring the lens assembly over with the focus gauge attached and bring the table up until it just touches on that particular marking location. Perfect. Now with the red diode pointer on, I'm going to put it right in the center of that location there. That's exactly where I want that mark to go. However, I want to rotate that part a little bit so we are marking on the opposite side. To do that, at the rotary, I'll use this button in the middle, which is a lock-unlock function. I'll press that button. You'll notice that the rotary then is unlocked, and I'm able to spin this around to any orientation that I want to use. That's the location that I want to mark right here. Once I've done that, I hit the lock button. That will lock the rotary in place, and we are ready with the laser to do the work. We'll turn our attention now back to the computer, and with this marking example, I want to show you sort of start to finish with setting up a job. We've done the part with the rotary, we've fixtured it in place, we've set the right diameter for that particular material, we found our marking location. If I'm doing a fresh job, I'm just going to bring up a blank page. In this case, this is 8.5 by 11, but that really doesn't matter. If I have a serial string that I want to engrave or mark on this part, let's just say it's 1, 2, 3, 4, 5. That's the image or the serial that I want to put on that particular part. One thing you'll notice about an Epilog laser is that what you see on screen is how it's going to be marked inside the laser system on the part. So what I want to do, first I'll zoom in on that image, is rotate that by 90 degrees so it's in the correct orientation to mark around the circumference of that part. I'm also going to make it smaller because that area, that marking field is of course much smaller than the font size that I had selected. This looks good. We're now ready to mark. So again, simple print icon, go to the preferences. This is going to be a raster job. I'm going to select center center. I'm going to set parameters that give me a nice deep etch into that material. So I'm going to go at about 20% speed and 100% power, and then I'm going to keep the frequency low as well. Once I've got that, everything looks good. I click OK. And then print, and then the job again is transmitted over to the laser. Once the job has arrived at the laser, everything again is set up here. I just simply hit the go button, and the laser does the rest. With multiple parts, it's fairly easy to bring a part out, to remove the part after marking, and then to reinstall a new part to keep the process going. So there's our job. It's done fairly quick. To remove it, I simply scoot the idle side support mechanism over, loosen the 3-jaw mechanism, and then there's our part. That concludes the marking demonstration for the webinar today. Hopefully you got an idea of the capabilities of the laser system, both from the software and driver perspective, the ability to use any type of software that our customers like, the functionality and ease of use of the print driver, as well within the laser system itself, with the large 24 by 12 work area, the ability to accommodate large parts, the ability to mark wherever we need within that 24 by 12 space, as well the ability to jig up smaller components. We hear from many of our customers that loading up the laser system and having their operator walk away and perform other functions in the shop is a great value to them. So in general, due to a heightened identification requirement need in the marketplace, manufacturers are looking for a way to quickly and effectively mark parts or components for tracking, for quality assurance, or for branding purposes. The powerful yet easy to use FiberMark laser system helps our customers to do that, which is why the FiberMark is finding utility in a wide variety of industrial markets. With that, we'd like to say thanks again for joining us today. Please stay online if you have questions. Submit those to us through the Global Spec portal. We'll be happy to answer those. Also, we'd like to offer our services here on our applications lab. If you have a material you'd like us to test, we'd be happy to do that. With that, thanks again and have a great day.